All right, hello math fans. All right, so we're going to do day 2 of chapter 1. So day 2. All right, so the first thing we're going to talk about are complementary angles. All right, and you guys already know that from geometry. It's the sum of two angles that equal 90 degrees. Those are complementary. Okay, supplementary angles. It's the sum of two angles and they equal 180 degrees. Okay, pretty easy. So here's just a quick example. If I said angle 1 is complementary to angle 2, I say measurement of angle 1 is equal to 2x plus 8 degrees, and measurement of angle 2 is equal to 3x minus 3 degrees. Okay, so I find the measurement of angle 1 and angle 2. All right, so the key here, guys, is the only tricky thing is don't set them equal to each other, okay, because they're not equal to each other. They're complementary. So that means you're just going to do 2x plus 8 plus 3x minus 3 equals 90. So 5x plus 5 equals 90. 5x equals 85. So x is equal to 17. Now this is a great ACT type question where that would be one of the answers on the answer blank, x equals 17. And a lot of people would put that because they would do all this work and figure it out. That's not the answer. That's just what x is. I'm asking you to find the measurement of angle 1, which is 2 times 17 plus 8, okay, which is 42 degrees. So that's angle 1. And the measurement of angle 2 is 3 times 17 minus 3, which equals 48 degrees. And of course, you know that if you add these up then, they have to equal 90 degrees. Just a good check. All right? All right, so let's talk about, we're going to do lots of stuff with angles here. So let's just kind of describe some of the different things here. This is called your vertex, this point right here. Okay, and your initial side. Okay, and this is usually, if we're looking at this as a Cartesian coordinate plane, okay, this is our positive x-axis. Okay, and that's going to be our initial side, and then this is our terminal side. Okay, pretty easy. And this is a positive angle. All right, and of course I can just draw this too. And I'm going to label this just to talk a little bit about that too. A, B, and C. And if I go this way, it's a negative angle. Okay, and if I want to label this or describe that that angle, name it. That's what I'm looking for. I could say it's angle B. I could say it's angle ABC, or I could say it's angle, excuse me, angle CBA. Okay, you notice there's our vertex. It's always in the middle, or it's alone. Okay, as soon as you draw something, and we're not going to have that, but as soon as you draw another line off of that B, right, you can't just name it angle B. You have to use 3 letters. All right, so we're going to use, there are 2 ways to measure these angles. We're going to talk about degrees for many, many chapters, and then we're going to talk about something else later on. All right, so I did mention before also, an angle is made up of 2 rays. I should really write that down here. Angle is made up of 2 rays. Okay, very important. All right, so let's talk a little bit about degrees. First of all, 360 degrees is a complete rotation of a ray. All right. This is, of course, 90 degrees. This is, and that's a right angle. This is a straight angle. That's 180 degrees. And of course, we can have this angle here, which goes around that way, a right angle, and that's 270 degrees, and we call this a reflexive angle. Okay? So, again, we're going to use the XY axis, or XY plane, with all of our angles. Okay, so just to kind of review here, the quadrants, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can remember that by drawing a C for cougars, right? So it starts out quadrant 1, 2, 3, and 4. All right? And this is our initial side, which is, as I kind of already described, the positive x-axis. And we call this standard position. So this is initial side, and if I draw another angle here, this is, again, our terminal side. Okay, pretty easy. Angles don't have to stop. So angles don't have to stop at 45 degrees. What they can do is, if I have an angle here and I go to 45 degrees, I can go around again and back to here again. So actually I can say 45 degrees plus 360 degrees, and I get 405 degrees. So it's the same terminal side, okay, it's just a different rotation. Alright, so I can even add another 360. And I get 765 degrees. So these are actually called coterminal angles. And a good definition is same initial and terminal side, but different rotation. Okay, that's what a coterminal angle is. So these are coterminal angles: 45 degrees, 405 degrees, 765 degrees. Those are all coterminal angles. Okay, so here, let's do an example now. Here's the question is, find the positive measure of the smallest angle coterminal to 1105 degrees. Okay, so basically what you're doing here, math fans, is you're saying 1105, and you've got to keep subtracting 360, because I'm looking for the positive measure of the smallest angle coterminal. So you keep subtracting 360 until you get the smallest value until you go before you go negative. So if we subtract 360, I get 745 degrees. Subtract another 360, I get 385 degrees. And I subtract another 360, and I get 25 degrees. And that's my answer, 25 degrees. Okay? Here's another question for you. Is negative 20 degrees coterminal to 700 degrees? Well, it is, because you're going to say negative 20 plus 360 plus another 360, and that equals 700 exactly. So the answer is yes. Okay, pretty easy. All right, so let's talk about a tachometer on a car. A lot of cars have these tachometers now to see how fast the engine is going. Okay, so you have as revolutions per minute. So on I used to own a 2002 Honda Civic. Great little car. Got great gas mileage, 40 mpg on the highway, or even more. And it's red line, we call it, red line, which is my max revolutions per minute. So it's revolutions per minute. Okay? And another word for revolution is a rotation. Because a revolution is going around one time, and that's what a rotation is. But that is equal to 6,800 RPM. That's the red line of my car. That's the maximum. And if you go above that, the engine could actually blow up. Okay? So you don't want that to happen. And a couple questions is, first one is how many revolutions per second? How many revolutions per second? This is revolutions per minute. And so again, remember, a revolution is a rotation, and a rotation is also equal to 360 degrees. Okay, so how many revolutions per second? Well, we're going to do something that you learned if you took chemistry. If you didn't, it's something that they use a lot. It's called dimensional analysis. All right, so what we're going to do is we're going to say 6,800 revolutions per minute times 1 minute per 60 seconds, and that gives us 113.33 revolutions per second. Okay, so the next question is how many revolutions in 6 seconds? So how many revolutions in 6 seconds? Well, that's just taking that number, 113.33, and so here, that's that number times, well, 6, right? 6 seconds. And the seconds, going back to here, right, the minutes cancel, and then if I have that times its revolutions per second, well, the seconds cancel, and I just get revolutions. So I multiply that out, and I get 680 revolutions. That's how many revolutions in just 6 seconds, which is a lot. All right, and the last question here is going to be how many degrees? Well, that's easy. It's 680 revolutions. And remember, on top here, revolution is a rotation, so there are 360 degrees per revolution. So the revolutions cancel, and we multiply that out, and we get 244,800 degrees. That's your answer. Okay, not bad. Okay, let's talk about portions of a degree. Portions of a degree. First of all, a portion of a degree, it's measured in minutes and seconds. Okay, so one, we use this little symbol here, like a single quadrant, like 1 foot, right? But that is a minute. And that's 1/60th of a degree. And we have 1 second, which is a 60th of a minute, which is 1/3600 of a degree. Okay, it's just like normal stuff, right? 60 seconds in a minute, 60 minutes in an hour. In this case here, it's 60 minutes in a degree. All right, so for example, if just writing this out in English, 37 degrees, 42 minutes, 25 seconds. That's how you say it. So 37 degrees, 42 minutes, 25 seconds. All right, let's talk about some computations now. So computations. Uh, 37 degrees, 42 minutes, plus 27 degrees, 17 minutes. Okay, we're just going to add together. 2 plus 7 is 9, 4 plus 1 is 5, so 59 minutes. 7 plus 7 is 4, carry the 1. 3 plus 2 is 5, or 6. So it's 64 degrees, 59 minutes. Okay, that's actually really pretty easy. What we're going to do now is do something just a little bit more challenging because things don't necessarily always work out so nicely. So here's the next one. Now notice I'm lining it up. It's really important to line it up. So 57 degrees, 39 minutes, plus 26 degrees, 42 minutes. Well, 9 plus 2 is 1. 3 plus 4 is 7, so it's 8. And 7 plus 6 is 3. 5 plus 2 is 7, plus 1 is 8. So you kind of add up the degrees together and you add up the minutes together. Now there's a problem here because that number needs to be less than or equal to 59 minutes. It can't, if it's 60 minutes, it's 1 degree more. So what you're going to do is you're really subtracting 60 minutes from that, and you actually get 21 minutes, and then that's subtracting 60 minutes or 1 degree. I increase this one by 1, so it's 84 degrees, 21 minutes. Okay, let's do a little subtraction here. So it's 52 degrees, 21 minutes minus 17 degrees, 37 minutes. Now it's kind of the same deal. I can't subtract 21 from 37. Or sorry, 37 from 21. I can't do that, right? I'm going to get negative. You don't want to deal with negative minutes. That's brutal. So what you're going to do is you are going to borrow a degree. So instead of 52 minutes, it's going to be 51 minutes, or 51 degrees. And then remember, when you borrow one, you're going to add 60 minutes to that. So it's 51 degrees, 81 minutes, minus 17 degrees, 37 minutes. That's easier to subtract now. And I'm going to get 4 and 40, so I get 44 minutes. And then I get 4 and 3, so 34 degrees, 44 minutes. All right, not too bad. Let's do one more little challenging problem here. 80 degrees minus 12 degrees, 13 minutes, 53 seconds. Well, what you have to do is you got to borrow for minutes and for seconds. So we're going to write this as 79 degrees, 60 minutes. But we got to borrow seconds too, so it's going to be 79 degrees, 59 minutes, and 60 seconds, right? That's still equal to 80 degrees because 60 seconds would bring that up to 60 minutes, which brings that up to 80 degrees. All right, so now it's going to be easy to simplify here, or to subtract. So we get 7 seconds, 6 and 46 minutes, and 7 and 6, 67 degrees. So that's your answer, 67 degrees, 46 minutes, 7 seconds. All right, that's it, math fans. If you're watching this video, you definitely need to bring your graphing calculator tomorrow for day 3. All right, that's it, math fans. You have a great day. Goodbye.